Okay, so the purpose of this video is just to take you through the simulation that you're going to be using and to make sure that you understand how it all works. Now there are some numbers up near the top of the screen. You're not going to be able to do anything with them. Those will give you readouts on information that you're going to be using. Over here you have a choice of different things that you could actually launch, such as a Buick or an adult human, to the tank shell, or user choice seems to be the default method. And you can set these parameters, so we can change the angle, for instance typing in 20 degrees, change the initial speed to 10, and so on and so on. Change the mass, the diameter of the projectile, that type of a thing. You could also turn air resistance on or off. For now we're just going to leave that off, and you can zoom in, actually that's zooming out, or you can zoom in, and so on to get a better view of what's going on. To the picture area. So this is your target, and you can move the target really however you like in order to really to change things if you want to. But for the most part what we're going to be dealing with is the cannon over here. And first let me just introduce this. This is kind of just a measure. It helps you get an idea of how far away different things are. And you can move it around like this. You can also take it over here and change not just the length of it, but the rotation of it, which may come in handy. The cannon. So if you grab onto the cannon barrel itself, you'll change the angle. If you grab anywhere else, you're going to change the height. And you can change the height to actually be very, very high, or down to the ground. And what we're going to be focusing on are a couple of different things. You're going to be looking at the effect of height on the optimal angle of launch. So as we increase the height here, what happens to the angle at which you need to launch it at in order to get the greatest distance? So that's our objective. We want to get the greatest distance of launch that we can, and how does that affect the angle? So you'll be doing really a graph of that. As you vary height, what happens to the angle that you use to get the greatest distance that you can. The next thing that we'll be doing also would be looking at the effect of the speed. So this speed here. How does, for instance, changing the speed by a certain increment change the distance that it goes? How does it change the time that it's in the air? So those are the two major factors that we'll look at with speed. So if we keep the angle the same, but we change the speed, how does that affect how far it goes and how long it's in the air? And then we can do the same thing with angle. So keeping the speed constant, let's change the angle and see how that affects how long it's in the air and how far it goes. So those are the three major sets of experiments that we'll be doing. Varying the height, varying the angle, and varying the initial velocity. And if you want to, you can continue on and do things like, let's take a Buick and throw in some air resistance and then fire that off, and you see what happens. So there's lots of fun that you can have with this one, but also you need to complete the experiments and keep track of the data, the readouts that occur there. The last thing that I'll point out is that there is a drop at the very minimum of 1.2 meters, because you're starting up here and you're ending down there, and I don't think that there's any way to actually have it launch from the initial height of 0.